first video in a series we're putting together about designing and building a workbench from scratch. So we'll look at selection of vices, types of timber and orientation, a few other design considerations, and then we'll kind of go through the design and build process so that you can follow along and hopefully build yourself a really functional, very solid workbench. When you're designing a workbench, there's a number of key points that you need to consider. The space that you're working in will really dictate the size and the shape of your workbench. So if you have a really small workspace, there's no point building a 2.4 by 900 millimeter workbench that takes up the whole space. So whilst we are building a specific size of bench here, I'll try and talk in principles that allows you to make yours smaller or larger if you need. The second thing is, what kind of clamps do you want to use? What kind of vices do you want to use? And what kind of tools do you want to use on the top of the workbench? So if you find that you're only going to use a vise on the end, then you can just install one of those. On the bench that we're building, we're going to put a shoulder vise, which is a Scandinavian style vise. It's a little less common, but allows really good free movement of the piece that you're clamping, allows you to clamp odd shaped pieces. And then we'll also do a more traditional end vise, which is the vise that you might have seen on a lot of woodworking benches and also metalworking benches. They're really versatile and easy to use. So once you've chosen the style of vise that you're going to use, you're going to actually have to go and look at the vise that you want. I'd recommend choosing it, bringing it home, and then you're going to really build the bench around the vise in a lot of ways. You want to make sure that you've left room to install it properly, that you're not going to have to be drilling holes in your main structure in odd ways. And so that's a real consideration, making sure you have room to place those vices in the bench that you're going to build, and it's not some afterthought. It's really the central reason that you're building a workbench, is so that you can hold work down in a secure way. That's why you need to think about it right from the beginning. The third really important thing for everyone who's building furniture, workbench, anything, is the materials that you're going to use. Now, I have a big pile of red gum here. Most of it is rough sawn, 150 by 40, 45, something like that. And I'm going to use that. It got purchased a while ago for this project, and it's just been sitting here. That's obviously what I'm going to use. But you might have something else. You might have a bunch of square stock that someone has given you or that you've purchased excess. You might have a whole bunch of dressed hardwood available to you, or you might decide that you want to build this out of something less expensive to begin with, like pine. That is totally an option, and you'll need to kind of shape your design around the timber that you want to use. And again, I'll try and keep this design process in principles that you can apply to whatever timber you have. The workbench that we're building will be built in separate parts, like most pieces of furniture. We'll be building the top, and then we'll be building the carcass in actually pieces that can be taken apart for transport and so forth. We'll start by talking about the top. You'll notice on the design here, the top is all vertically jointed hardwood that gives me a really nice thickness. So the reason it's done in this way is that if I just laminated the timber like a standard tabletop, we'd be limited to the thickness of the timber that I have, which is going to end up being about 35, 40 mil, something like that. That's just not quite thick enough for a really solid work surface like this. What can tend to happen is, even though this is really nice dried furniture timber, any changes in humidity could introduce slight warping, which means we don't have a useful true surface. So what I'm going to do is actually rip these 150 by 40s down the center, put them on edge and glue them all together. That means I can get a top that's around 60 to 70 mil thick and as wide as I want. Any warping in an individual board that happens over time will be resisted by every other board, and it's an incredibly strong join because you've got so much surface area. You'll also notice that over the whole top, all of the timber is going in the same direction. I'm not bordering it with horizontal pieces or end pieces on each end that take the grain in a different direction. As our timber for the main workbench is running all in one direction, that has a tendency to expand in the direction across the workbench and not so much within the length of the workbench. If we introduce a second piece of timber that goes across that, we're introducing a bunch of stress when these pieces expand and this one doesn't want to. I want to avoid that, and I think unless you are very experienced with dealing cross-directional grain stress, you should probably avoid it too. This is still a really, really strong way to build, and you just don't need a cross piece on the end like that. You'll also notice that the grain direction for the shoulder vise is running exactly the same way, and that's for the same reason as I just described. Okay, I'm going to hide that tabletop and we'll start talking about the carcass a little bit. So the carcass itself, obviously a super important part of this whole build. If it's wobbly or weak, your workbench is going to be almost useless. So it needs to be very, very solid. For that reason, it is over-engineered. Big pieces of timber, there's a lot of weight in it. We want to make sure those joins are really strong. And the way that we're actually going to build this is we're going to build the two end frames as solid units but separate, and then we're going to add 4 rails in using these workbench bolts. And when we go to the install process, I'll show you how they work. But basically, it means that our end components are all glued together and they're solid, and the rails are actually tightened with bolts, which allows us to knock it down and put it back together if we need to. It also allows us to get an incredibly firm join that we can tighten. We can tighten it later on if humidity changes the thickness of the timber at all. It just means we can remain a super solid workbench while also having the ability to fold it down for transport if we need to. So I'll remove the rails from this image so that you can see how the end components are made. So you'll see from the computer screen that the two end assemblies are slightly different. The reason for that is this long arm on the rear end assembly is actually to support the weight of the shoulder vise. There's nothing complex about it. It's just a longer rail on the top there to make sure that that weight is fully supported. But we'll talk about the design of the actual end assembly just by using this one in the foreground here. As I mentioned earlier, I have a whole bunch of 150 by 40mm rough sawn stock, so that's what I'm going to use. But I still wanted a really thick workbench leg. What that means is I actually need to laminate multiple pieces together. There are multiple ways to do these kinds of joins. You could dress all of this timber down to, 130 by 35, laminate them all together to make really solid blocks, and then you could do full mortise and tenon joins that would be really super strong and lovely. And by all means, if that's the way, that's what drives you, that's what you want to be spending your time doing, and that's what you want to put into your workbench, definitely do it. And I applaud you. But for this design, in order to keep it as simple as possible and accessible to most people, we're actually going to be using lap joins, which are just a little simpler and a little easier to put together, and in some ways less time consuming. And they'll be just as strong for this kind of workbench that we're building. So when we're looking at our leg assembly, we're actually looking at 2 pieces laminated together for the entire thing. That's just to get the thickness that we're after. You'll notice that we've got these really large lap joints that are really simple and strong. So the way that this is going to work is we're actually going to create the horizontal components and the vertical components separately. So you'll notice in this design, I've actually got those cutouts there. We're going to join that horizontal component, both of them, as if it was one solid board, and then we're going to cut that section out. To make that a little bit easier, we're actually just not going to glue that one section that we want cut out. We'll glue everything else, and that way, when we are sawing that off, we won't have to spend as much time chiseling and flattening that section out, but we'll get a really nice, perfectly square, flat join. The same thing applies to the verticals. We will laminate them together as if it was one solid piece, and then we will cut out those notches for the lap joints. So it's a simple way to get a very strong frame. We'll do exactly the same thing on the other end. The only difference is that we have a slightly longer top horizontal crossbar to support the weight of the shoulder vise. Okay, last thing to think about in this design are the crossbars. Now, Again, because I'm using 150 by 40, I'm going to laminate 2 pieces together to get really nice solid beams. You could potentially get away with less. You do need that height though, and that prevents the entire frame racking and twisting. That's where a lot of that strength comes from and stability. So I'm going to use full, 140s, whatever these dress down to, laminated together to about 140 by 60 as my beams. And I'll use 4 of them, and they're going to be joined into my end components using the workbench bolts. So this brass lug actually sits inside the beam, it gets drilled in, and then this bolt, the silver gal bolt, comes through our end assembly and tightens the beams into the end assembly. We'll go through that in detail, but it's a really handy and simple way to make a very, very strong join. So we'll use one of these on each of the beams, and like I said, it means that you could potentially tighten it if you need to, or take it apart for transport. Just a couple more design considerations before we get into selecting and dressing up this timber. The first one, we've put our rails up above the ground by about 250 mil. That's so that we can put a shelf there. It's not drawn in this diagram, but it gives us a little bit more storage. The other one is a really important consideration, is how high you're going to make it. I would start at something like 900 mil. It seems to be a pretty universal work height for a variety of workbenches, but there's some really important things to think about. If you're really short, you might want it shorter. If you're really tall, you might want it taller, but it also really depends on the kind of work you do. So in my workshop, I actually have a couple different heights for workbenches. With the workbench where I'm doing a lot of sanding or using a circular saw or another machine, I actually want it slightly lower. So they're sitting at about 800, and that means I can put weight down onto the sander or the other machine that I'm using. That's a large assembly style table where I do a lot of that heavy sanding style work. For finer hand work with chisels and hand saws, you might want it to be higher so you're up closer to your work and you're not having to get down as low. So this one, for instance, is about 950. That feels like a good height for doing dovetails or something like that, for instance. Now the process is about going through our timber pile, selecting the pieces that are appropriate, and then, if you have to, you might need to go back to the design and just tweak things a little bit to make sure that it all fits with the timber that you have. So, when you're selecting pieces for your top, make sure when you cut them down, if they have a huge sap line or a hole, you're either willing to fill that with resin or you're going to choose another piece. Also, if you pick up a piece and it's got a big curve in it and it's rough sawn, just know that you're going to lose some of that thickness by the time you've milled it down. I'm going to get my timber in here. I'm going to select the pieces I want to use for what. I'll write all over it with chalk. I'll dot them to length, but not exactly. So my bench is going to be about 2.1 meters long. I'll cut them to say 2.2, 2.3. Get them as close as I'm willing to that final length so that I'm not overdressing extra material. It's just extra waste and extra time. Also means that if you've got a longer piece and it has a curve in it, any amount that you can cut off reduces that curve and reduces the amount of waste that you're producing. So once I get all of my pieces labeled, cut down to rough size on the drop saw, I'll take them to the jointer and get 2 good perpendicular edges, a face and a full face and an edge, and from there I'll take it to the thicknesser and get everything dressed up to its final dimensions. I'm not going to go through and show you that entire process because it bores even me and you don't need to see it. But next time we're going to actually go into doing our final cuts on our dressed timber and getting everything ready to start doing some of these joints.